Hi, my name is Jack, and this is cycl2, and this is my second semester, and today is September 14th. Today we're going to talk about switch technologies, and this cycle is about 5 chapters, which are 5, 7, 8, 9, 10. Analyzing Ethernet LAN switching, configuring and verifying switch, implementing Ethernet, spanning tree protocol, RSTP, and Ether channel. So, before we get deeper, let's talk about switch first. What is switch? Switch is the device which is making connections with other devices and connecting multiple hosts. As we can see in the picture, our computer and data center is connected with various switches. By the way, this is a switch icon in Cisco network. Don't get confused with other one. We normally use LAN switch and it forwards Ethernet frames. LAN switch has only one primary job to do. As I mentioned, it forwards frames to the right destination address. Also, LAN switches receive Ethernet frames and make a decision forward the frame or ignore the frame. In this process, switches show 3 actions. First, deciding when to forward or when to filter a frame. Second, get prepared to forward frames by learning MAC address by examining the source. Third, preparing to forward only one copy of the frame to the destination. It means a network loop occurs when a network has more than one active information from the same source to the same destination. Let's talk about MAC address. It is unique hardware address of single network adapter, and IP addresses can be changed by user, but MAC address cannot be, because it is unique identifier to the network, which means it is unique hardware address of the network adapter. And how to figure out my MAC address is very easy. Go to command line and do ipconfig/all, and well, sorry for Korean because I'm using Korean interface, but it should be physical address and show the MAC address like that. Now let's talk about flooding, unknown, unicast, and broadcast frames. This is very interesting topic to learn because the word flooding in network, it means there must be a problem and we should solve it. So, flooding means the switch forwards data to all ports. However, if host is sending data to unknown MAC addresses, it will be flooding and the switch will spread the data everywhere. Switches also flood LAN broadcast frames. The reason is this whole process helps deliver a copy of frame to all devices in the LAN too. Look at the picture. Fred sends something, and when switch's MAC table is empty, what will happen? As I said, switch will send the data everywhere. In chapter 7, we're going to learn about configuring and verifying switch. First, we will learn about configuring and verifying switch because sometimes when we're dealing with network cable, we need to know about it. We need to decide which ports should be enabled and disabled. I talked about shutdown command before in cycle 1 presentation, and when we put shutdown command, it means disable, and no shutdown is enabled in interface. Look at the picture. What we see is command shutdown in interface fast Ethernet 0/1 port, and this one is disabled. So bringing back up the interface again, we will do the same process, but put no shutdown. Great example is this one. I will show you how to remove configuration with no command once. The picture shows our running config interface, and we have listed process and we want to turn them off. What should we do? Is put configure terminal and put no in front of all listed interfaces. That's it. Very simple, right? Next. Also, if you're not sure about our port status, I strongly recommend to use interfaces status command. This lists exactly one line of interface, whether it is disabled or enabled. However, putting show interfaces without status word will list the whole lines of interfaces. Next, auto negotiation. I was having trouble with understanding the meaning of auto negotiation, but simply it is just an interface can run at different speeds and automatically determine the speed and duplex setting to use. Because when speed and duplex mode is not matching together, we will have serious problem called late collision. It can cause critical error and decrease network performances. So what is late collision? Is it literally just late collision? Like happen after or late? Yes, it is. The normal collision in Ethernet, common crashes occur before the first 64 bits of frame transmission. But if collision happens after we send 64-bit, we call that late collision, because it is late and didn't happen in the first place. Late collisions are not normal events and it is not even considerable problem nowadays, but we should solve the problem as soon as we find late collisions because, as I said, it can cause critical error and decrease network performances. We don't want that to happen, right? Alright, so back to the topic. This is a picture of auto negotiation. As we can see in the picture, devices are set up and there are 3 pairs and the wiring supports 10 megabytes per second, 100 Mbps, I will just call Mbps, and 1000. Ethernet options, both nodes are sending auto negotiation messages, and switch shows all 10, 100, 1000 ports. I will use one PC as an example. Look at the PC2. We see that the best speed is 100 Mbps and it's time to negotiate with switch. So the switch port and NIC negotiate to use 100 because it is the best speed and full duplex. So we should learn how to confirm our PC is safe from late collision or other problems, right? So in CMD, we put show interfaces fast 0/13 as this picture and see the result. I will point out the most important points we should check, and it's also underlined. Runts is frames that didn't meet the minimum frame size requirement, and giants is opposite. Frames that exceed the maximum frame size requirement. Input errors, total of many counters, runts, giants, and others. CRC is received frames that didn't pass the FCS math, which can be caused by collisions. And output errors are total number of packets that the switch port tried to transmit. Collisions, as I mentioned, collisions that occur when interfaces transmitting a frame, and late collisions are the subset of all collisions happen after 64-bit of the frame transmitted. Chapter 8. Implementing Ethernet Virtual LANs. VLAN, Virtual LAN, creates its own broadcast domain, while LAN includes all devices in the same broadcast domain. And communicating with 2 VLANs can happen through a router which is connected to both. And let's talk about VLAN trunking. VLAN trunking means if the network created various VLAN, trunking will send them in once. For example, there's so many VLANs in switch and each one needs its own link. However, it can cause complicated and various links, so that making a combined link and sending source through it. That's trunking. To distinguish each frame each frame in trunk, they mark each VLAN, and even it is transmitted through the same port, trunking sends the frame to the right destination. So, what if our switch is divided like this? Don't worry, we have a router. Switch doesn't route between the VLANs because the network must use a device acts as a router or some functions like a router. So about this split this switch into parts with two different VLANs. Left is VLAN 10 and right one is VLAN 20. Now we have a router in the middle and it has one LAN physical interface connected with two switches, which are VLAN 10 and VLAN 20. In this part, the layer 2 switch can keep doing its job, which means they need a router to forward frames inside the VLAN, which is routing IP packet between the subnets. Chapter 9. Chapter 9, Spanning Tree Protocol Concept. Let's start the chapter with STP and RSTP basics first. As I mentioned before, STP spanning tree protocol can prevent loops by blocking link as RSTP. So, what we need spanning tree, basically it is for looping. Just one looping causes broadcast storm. Broadcast storm means any kinds of Ethernet frames loop around a LAN indefinitely, and multiple copies of the frame will arrive at the destination, meaning that our network is going to be down. Let's see the picture. This is what happens if there's no STP RSTP. Everyone in the network is sending data to each other, and in the network it keeps looping and looping until something changes. For example, we can stop with shutdown or break that loop. So I just put some blue guy with thunder. So in this case, what STP and RSTP can do is blocking the way or cut off the way so that we can break the loop. Comparing STP and RSTP. So what is different between STP and RSTP? Well, RSTP works as STP, but STP takes longer time to detect because of the delay time when switch is detecting loop is longer than RSTP. So comparing with STP and RSTP defines more cases with the switch can avoid. Chapter 10. RSTP and Ether channel configuration. Recently, Cisco iOS switches provide default to using RSTP rather than STP because RSTP works with no configuration and it interoperates with STP2. This picture is typical config choice to making distribution switch be root. The meaning of root is reference point for all switches in spanning tree topology. In the picture, we can see access switch between distribution switches and PC. It means access switch is used to connect to endpoint devices. It is always in the middle and do access work. And distribution switch, as we can feel from the word distribution, it distributes and switches that do not connect to endpoints. In this slide, I will talk about our RSTP configuration options. First, port cost, switch priority, and primary and secondary root switches. First, port cost. The interface is spanning tree, VLAN, blah blah, and let us to set the switches STP, RSTP cost on the port. Also, the reason why we gave root to the distribution layer is that in access layer and devices are connected and the root bridge should be close to the router connection for fast connection to get out in less time. Therefore, we should give the distribution layer the root bridge and the secondary to the layer. So if there is a root bridge on the access layer, you should change it. Next is switch priority. The command is spanning -3 VLAN and number, priority and number, but in this example it shows MST2 instead of VLAN and priority 4096 as number. So let's consider that I put this command in here, and to check I did the right job or not, command will be show spanning -3 or do show span VLAN and number, or MST and number as this picture. And switch to priority has set it up like this. Next, primary and secondary root switches. The command is spanning -3 VLAN number root primary. This also let me set the priority. However, the switch decided on a value to make a primary root switch or secondary root switch. If we want to see switch priority value after we set it up, we can put show spanning -3 to see the whole interfaces. And this is my citation. I use 6 different sources, but basically most of the things are coming from our book. Thank you for watching, and also for this video, please give me some comments or any recommendation, or is there anything I'm missing, or is there any wrong information? Please tell me, because I'm not perfect and maybe I might misunderstood some information. Thank you.